Welcome to the DIY Honda Garage channel. DTC C1248-1D indicates a problem in the electronic vacuum pump system of the Honda Civic 2022 and later models. This diagnostic trouble code, DTC, signals that there is a potential short circuit in either the motor plus or motor minus lines, which may affect the functionality of the electric vacuum pump. The electric vacuum pump plays a critical role in the braking system by providing additional vacuum pressure, which ensures optimal brake performance, especially when the engine vacuum is insufficient. The pump is typically located in the engine compartment, and it is controlled through an electric vacuum pump control unit. This unit monitors the electrical currents and signals to ensure that the motor operates correctly, storing a DTC when it detects abnormalities. Therefore, identifying and addressing this issue promptly is crucial for maintaining the vehicle's braking efficiency. The electric vacuum pump is a vital component responsible for generating vacuum pressure necessary for the brake system to function efficiently, especially in situations where the engine does not produce enough vacuum. It operates under the guidance of the electric vacuum pump control unit, which interprets electrical signals and controls the motor's operation. This control unit is designed to detect irregularities by monitoring the current in the motor plus and motor minus lines. Should these current levels indicate problems, the unit will store the DTC, in this case C1248-1D. The electric vacuum pump is generally located in the engine compartment, connected to two terminals, motor plus, EVP MTR plus, and motor minus, EVP MTR minus. Proper functioning of these components is essential for reliable brake performance. Thus, a malfunction can lead to compromised safety while driving. Several factors could lead to the activation of DTC C1248-1D. The most common cause is wiring issues, such as a short circuit within the lines connected to the electric vacuum pump. A short can occur due to damaged insulation or poor connections that allow wires to touch each other. Another possible cause could be a malfunction in the electric vacuum pump control unit itself, which may fail to properly monitor or respond to signals, thus leading to incorrect performance. Lastly, the electric vacuum pump may be defective, meaning it could fail to generate adequate vacuum pressure, even if the wiring and control unit are functioning correctly. Each of these potential causes must be examined thoroughly to diagnose the root issue affecting the vacuum pump system. When DTC C1248-1D has been triggered, several symptoms can manifest within the vehicle. One noticeable symptom is a decline in braking performance, which may become more apparent during deceleration or when the brakes are applied. In some cases, the driver may notice that the brake pedal feels abnormal, requiring more effort to engage the brakes, indicating that the vacuum pump might not be supplying enough pressure. The vehicle's dashboard may display a warning indicator light, signaling a malfunction in the brake assist system. Unusual operational sounds may also be present, such as grinding or whining noises coming from the electric vacuum pump itself, indicating internal issues with the pump. Recognizing these symptoms promptly can help ensure timely repairs and maintain safe driving conditions. The first step in troubleshooting DTC C1248-1D involves properly bringing the vehicle into the necessary operational modes. Start by turning the vehicle to the on mode, which activates the electrical systems without starting the engine. This step allows for comprehensive diagnostics and ensures all electronics are working correctly. Following this, turn the vehicle to the off mode and allow a waiting period of 2 seconds. This transition period can help reset electronic systems and clear any temporary glitches that might affect the diagnostics. By completing this initial step, you set up an accurate platform for subsequent tests to follow, ensuring effective troubleshooting of the vacuum pump motor issue. In the second troubleshooting step, you begin by starting the engine. This action generates necessary power to all components, allowing the electric vacuum pump to operate as intended. After starting the engine, wait for 1.5 seconds. This brief pause permits stabilization of engine functions, ensuring that all electronic signals can be accurately measured. Once this time has elapsed, the next action is to press the brake pedal and perform pumping. While doing this, you should closely observe the response of the brake system, noting any irregularities or lack of assistance from the brakes. By executing this step thoroughly, you can collect initial information about the operation of the vacuum pump before proceeding to further inspections. The third step in the troubleshooting process focuses on inspecting the external circuit associated with the electric vacuum pump. Start with checking the Motor Plus, EVP MTR Plus line for any visible signs of shorting, such as damaged insulation or exposed wires. A thorough visual inspection here can help identify obvious faults that could affect the circuit's integrity. Next, perform the same assessment on the Motor Minus, EVP MTR Minus line. Short circuits in either line can lead to the electric vacuum pump malfunctioning and the storing of DTC C1248-1D. Ensure that both connections are secure and intact to facilitate proper current flow. Completing this external circuit inspection is an essential step in diagnosing the root cause of the problem. In this fourth troubleshooting step, you will turn your attention to the inspection of the electric vacuum pump. Begin by disconnecting the electric vacuum pump's 2P connector, which isolates the pump from the control unit and electrical circuit. Once this is completed, proceed to perform the wire inspection by checking both terminals of the connector, Motor Plus, EVP MTR Plus, and Motor Minus, EVP MTR Minus. It's vital to ensure that there are no shorts present within these wires, as any shorts can lead to incorrect readings on the electric vacuum pump assembly. The inspection phase should include using a multimeter to check continuity. If any abnormalities are noted, such as a shorted wire, the issue will likely lie within the wiring rather than the pump itself. Once all necessary repairs have been completed in response to DTC C1248-1D, it's crucial to verify that everything functions correctly. Start by reconnecting all components that were previously disconnected during troubleshooting. This includes the electric vacuum pump's 2P connector, which should be secure to ensure a reliable electrical connection. After reconnection, the next step is to clear the DTC from the vehicle's onboard computer using an automotive diagnostic tool, such as the Honda Diagnostic System, HDS. Once cleared, conduct a functionality test of the vacuum pump system. This test involves starting the engine again and observing the brake pedal feel and performance under normal operating conditions. Successful operation after these steps ensures the issue has been resolved and the vehicle is safe to operate. To prevent future occurrences of DTC C1248-1D and to maintain the functionality of the electric vacuum pump, regular preventive maintenance is vital. Schedule routine inspections of the electric vacuum pump and its associated wiring to identify potential issues before they escalate into serious problems. Performing visual checks and tests for continuity in the wiring ensures that wear or damage is addressed promptly. Additionally, evaluating the operation of the electric vacuum pump periodically can help catch any developments in performance issues early on. Proper maintenance practices not only increase the lifespan of these components, but also enhance overall vehicle safety and reliability on the road. In summary, DTC C1248-1D signals a key issue within the electric vacuum pump system of the Honda Civic 2022 and later models. Understanding this code's importance allows for more targeted troubleshooting, ensuring prompt and effective action in resolving performance issues. By following the specified troubleshooting steps diligently, technicians can systematically identify whether the issue relates to wiring, the control unit, or the pump. Proper repairs are crucial for maintaining the functionality of the braking system, ultimately ensuring driver safety. Adhering to preventive maintenance guidelines will help sustain vehicle performance and keep future DTC occurrences at bay, contributing to a safe driving experience. Please like and subscribe to the channel. See you next time.